God. Okay, I'm Lowell Katie, and we're going to start talking about LabView and go over some of the basics. First off, if you've already got LabView installed, you're going to need to find LabView in the National Instruments section. Now, I've got a whole bunch of different versions of LabView. I'm in the ends here. I'm going to use LabView 2023. No, actually, yeah, what the heck, 2023. I haven't used that one. We'll see what's in there. This is what you should see when it starts up, and it should ask if you want to open a blank VI or a blank project. Boy, takes a little while to open, doesn't it? All right, we're going to create, well, what I want to create is actually just a regular old VI, which means virtual instrument. But since everything's blank here, let's go with create a project. A project is a group of virtual instruments. Again, VI is virtual instrument. So we're going to take a look at this in just a moment. As soon as it gives us all of our options, apparently, we're going to go with a blank project. So I've selected blank project, and I'm going to say finish. Little window opens up, and there's nothing in there. There's no programs yet. It also doesn't have a name. And our program is going to be called it is a virtual instrument. So I'm going to right click on this. I want a new VI. A VI has a front panel and a block diagram. I'm going to set these next to each other so that we can see as I add things to the front panel, you will see them show up in the block diagram. There are a number of tools that you can add to the front panel. I'm going to stay a little bit old school here, and I'm going to use this silver set. Mostly it's because that's what I'm familiar with. So I'm going to say, let's do a really simple program, and what it does is going to add two numbers together. So I'm going to select from the numeric. I'm going to take a numeric control and drop that in, and you see a numeric shows up in the block diagram. I'm going to take a second numeric and place that in, and then I need an indicator. What we're going to do is we're going to add these together and display the value. So I went to numeric indicator, and all three of the objects on the front panel are now represented by icons in the block diagram. Now I'm going to right click on the empty space in the block diagram, and I'm going to select a numeric palette of tools, and we're going to just do something really simple, just to add. So I drop that in, and it looks like an addition gate. That is one of the themes that you're going to see in LabView, is that there are many symbols that look a lot like schematics. It's a clever way that they came up with to make a programming language. The language is considered a data flow language, so we're going to wire. I'm going to move my mouse over to the corner, to the edge of the first numeric, and it turns into a little spool of wire. One thing to note, if you don't have the automatic tool selection, I believe it is in, I never changed this, let's see, View, Tool Palette. You see it popped up over here. So if you want the automatic tool selection, you would like it, you can set this little thing to green. If you don't want it automatic tool selection, it's turned off, so it's black. Now, if you don't have automatic tool selection, you go back over to the same place, you don't have anything. So let's see, what is it? Tab. You have to press tab until you get your tool. So in this case, we want the wiring spool. And we're going to connect the wire spool to one of the inputs of the gate. Now, I'm going to turn automatic tool selection back on. And actually, I'm going to close this because I just like to have automatic tool selection. And we're going to wire up the second numeric to the second input of the gate. And then the output is going to go to numeric number 3 now. I want to know what 1 plus 2 is. So I went over to the front panel and I put 1 into numeric 1, 2 into numeric 2. I'm going to hit this run arrow, and that is going to execute the code. And numeric 3 now has the number 3 in it because hopefully 1 plus 2 equals 3 where you live, like it does here. And that's a pretty basic, that is a really, really basic program. It only executes when you hit the run once. Now, we could do something silly, like we could say run continuously, and then whatever numbers I put in here are going to get added together. And there's a little stop symbol. And again, very, very basic program. That's just to give you an idea of what controls and indicators are. That's not really how you would make a program, an actual program. An actual program would run on its own, and it would have buttons to activate things. And we're gonna talk about that. But for right now, let's do something that, let's say we were going to do an add or a subtract. We could potentially put a subtract in here, and we could wire these two together in parallel. So we have an add and a subtract, but we still want the output to go to numeric 3. So there's a decision-making process, and I'm going to go to the comparisons. I'm going to go to select. And what that's going to do is going to allow me to select based on a Boolean value. What I'm doing here is I'm right-clicking and I'm saying create a control. So it just created this control right here, and I'm going to label that control. By default, it just says S. I'm going to label that control as add. And when that's on, we'll be following the add logic. So I'm going to connect that true to add. I'm going to disconnect by selecting the wire going to numeric 3 and hitting delete. And I'm going to connect the output of the select to numeric 3. And I'm going to connect the false side of the select to the subtract. Now, what would be nice is if we know that when it's true, it's an add, and when it's false, it's a subtract, but there's nothing to indicate to anyone that that's what that operation is. Let's have a look at something for a minute. I just closed that box. We can get back to it by right-clicking, and then we have access to our tool palette again. If I right-click on this Boolean button, there are properties. And one of the properties, I hope, is some Boolean text. And we're going to see the word, when it's on, we're going to say add, and when it's off, we're going to say subtract. The only bad thing about that text is we can't really see it. So I'm also going to resize this, and hopefully we can see it a little bit better. Not the best ever, is it? It's not great. There are other buttons that can be used in the place of this. For instance, let's go back to silver, button type. Oh, there's some that actually have add and minus, so that's not really what we wanted, not what I wanted. Let's say it's just a blank silver button. Matter of fact, instead of doing it that way, I'm going to replace this. I right-click on this, which is already wired up, and replace it with the button, blank silver button. And that should retain all of the settings that we just had, but as a matter of fact, instead of calling that add, we'll just call it function. So now, I'm going to go ahead and run continuous on this again. You can see that it is subtracting 4 from 9. If we change that to add, now it's adding. So again, very basic functionality. Go ahead and stop. But let's do something that is a little bit more interesting. Okay, so what we're going to do is we're going to look at some of the other standard programming functions. For instance, a for loop. What would a for loop do? Well, let's say that we wanted to run this entire thing 4 times. And what I'm doing is I'm putting everything inside of a box. So that box is going to execute, in this case, I'll just say 4 times. And instead of using numeric 2, I'm actually going to use the count of the loop. And instead of making numeric 2 an input, a control, I'm going to change that to an indicator. And I'm going to hook numeric 2 to the loop. Now, here's the thing. When I hit this once, it's just going to go past really, really fast. And we didn't see anything happen. We just see that 9 minus 3 equals 6, but we didn't see 9 minus 0 equals 9, 9 minus 1 equals 8, or anything like that, because it went as fast as it possibly could. So there is another tool under timing, and we're going to put a wait in here, and we're going to cause the program to pause, and I said create a constant, and this is in milliseconds. So let's wait 750 milliseconds. And I'm going to run it over here. You're going to see numeric 2 go to 0 because this is an iteration. That's what I means. And the first iteration is 0. The second one is 1, then 2, then 3. Iteration 3 is the 4th execution of the loop. So here we go. 0, 1, 2, 3. And the program's finished. So for loops are ways to cause multiple iterations, and you don't always have to wire this number. Sometimes you might have an array, and when you wire an array into this, it automatically will set the number of loops that are going to get executed. But I wanted to explain what that for loop was. Similar to the for loop, I'm going to go ahead and remove the for loop, and I'm going to now put in a while loop. What is a while loop? A while loop will execute forever until some condition is met. And in this case, I'm going to create a control that's going to be a stop control. So now it is going to run forever until I hit stop. As soon as it reads the stop, the loop stops, and because this is the only thing in the program stops. Now, Sometimes you want a user to stop a loop, but sometimes you want a condition to stop a loop. So let's get rid of that stop button, and let's say if the iteration is equal to value, I'm creating a constant of, I don't know, how about 13? If it's equal to 13, then we're going to stop and run. And maybe 13 was too big of a number. It's going to take a while. But anyway, when it gets to 13, it should stop. There we go. And why did I do that? I did that just to illustrate that there is a comparison palette, in which case, you have equal, greater than, less than. There's a number of other logical operations that can be done there. And I think, you know what, we're going to do one more, and that's going to be an event. And an event would normally live inside of a while loop, and events are usually things that are operator initiated. So I'm going to drag all of these things outside the loop for a moment, and I'm going to create an event. So it's under dialogues and user interface, event. We're going to create an event structure, and we're going to draw it inside of the while loop. So what does this mean? Basically, any user operation that can happen on the front panel will be an event, or could be an event, that happens in the loop. And a timeout is basically, it's not doing anything. It's not doing anything, and it's waiting for some event to happen, but nothing happens. By default, the timeout will wait forever. A -1 wired to this little hourglass means it's going to wait forever. Don't do that, because it really will wait forever, and you won't be able to stop your program sometimes. So don't use a -1. A good responsive user interface might be 109 milliseconds. Every 109 milliseconds, the timeout event is going to execute. Does that mean we want the program to stop at the first 109? No, we don't. So I'm going to the Boolean palette. I'm taking a false constant, meaning I do not want this to happen, and I'm wiring it to the stop. Of course, I do actually want the program to stop. So what is that going to be? Well, let's go ahead and make a stop button. I'm going back to the buttons. I'm going to put a stop button in here. And we have a stop button. That's not in the right place. I'm going to create an event. I'm going to add an event case, and it's going to be for the stop button when the value changes. Now I have a brand new event. I'm placing the stop button in there, and I'm going back to my constant. This time I want a true, and I want the output to cause the loop to stop. All right, all of that. One more thing we're going to do, back to silver, we're going to do the add button, and we're going to do, it's called a remove because it's not really meant for math, but we'll call it a subtract. We're going to have an add button and a subtract button. These are going to be two different events, and they're going to read numeric 1 and 2. I'm going to change this numeric back to a control. And actually, we're going to get rid of this function. We don't need that anymore. Don't need that anymore. And we're going to start with the add. So we're going to wire this up for the add, and then we're going to put this into a new event for when the add button gets pressed. We'll go up here to the box and say add an event case for the add button. Put the add button into this box. We're going to place our numerics in there. We also don't need this timer anymore. But what about the subtract? We want to add a new event case for the subtract button. Here's our subtract button and our subtract event, but we want to reuse numeric 1, numeric 2, and numeric 3. We just want a different function. And this is the part where there's lots of ways to do this. You could read these values outside every time maybe the timeout occurred, but I'm going to do it kind of a, I don't know, a cheating way, whatever. It's the way that the data flow people of Lavbiew say don't do it, but it works for our purposes. Maybe I'm teaching you a bad habit. Only time will tell. All right, so we have numeric, and I'm going to create a local variable. And move that guy down here. Go to numeric 2. I'm going to create another local variable. In numeric 3, we're going to create another local variable. Now, instead of the add event, we're going to the subtract event, bringing everything in. Oh, not that guy. Drag him in here. I have to change this to a read. Change this one to a read. This guy's still a write, so we don't have to do anything with that. But we need the math to be subtract. And we have add, subtract. So what we did is we're not reading the numeric control directly. We are reading it out of memory, and we had to create a memory space, a local variable, for it to live. Okay, I'm going to run the program, and I can change these. You can see the program's running. Nothing's happening here. If I add them together, we get a number, and if I hit subtract, we get a different number, and I'm going to look at the stop, and if I hit stop, program stops. What you didn't necessarily see is that all of the other times that we were not pushing these buttons, the timeout event was happening. Now there's nothing in the timeout event, and let me illustrate that by creating an indicator, and that indicator will show us our timeout count. So we'll just call it timeout count, and it will just show us how many times the timeout occurred. So let's run again. All right, look at that. It's timing out. It's executing the code that's in here, and you know what? It doesn't care, right? Now if I hit this a bunch of times, you see that now it's doing the other event. It's not doing timeout anywhere near as often, but it still is doing timeout. I'm not doing anything, timeout's running. Why that's important is you wouldn't want the timeout to execute every millisecond, right? You'd probably want the timeout to execute in a way that is useful update on the screen for an operator. So I usually pick around 1/10 of a second, around 100 milliseconds. I also choose prime numbers for the timeouts so that just in case, I really hope 109 is a prime number, I honestly don't know. But I try to pick numbers that aren't common. The reason why is I write a lot of these programs, and a lot of the times I end up with a whole bunch of loops all executing. I don't want them all to be executing at the exact same time. I want them to be requesting the memory at different times from the system. So one loop might be running at 109 milliseconds. Another one might be running at 114 milliseconds. Maybe not 14. That's not definitely not a prime number. But anyway, that's going to be it for today, I think, because I got to cut this video and it's getting pretty long. So hopefully this is enough information to get you underway. You know what? There's one other thing. Now that I'm thinking about it, we didn't save it. Do a file, save, and I don't know where this is going to save. So let's just do a save and see what happens. I don't want it in that project. How about I make a brand new project called Lavbiew lesson. Oh, I spelled it wrong. How about Lavbiew class? And we'll call this basic and basics.vi. Now the name is there, and I'm going to close this, and sure enough, it's in our project. The project doesn't have a location, so I'm going to save the project as, and we'll call this our Lavbiew. You can name it whatever you want. Lavbiew class, project 1. There you go. Hope that was helpful.